Hello, so today we are going to do this problem, construct string from binary tree, which is part of this week's Leetcode daily challenge. So the problem says we have a root of a binary tree, and we want to construct a string that contains parentheses and integers from the binary tree using pre-order traversal. So what do they mean by these parentheses and integers? But the piece that is important is that we want to use pre-order traversal. So remember that means the root first, the node processing the node first, and then going left and going right. So parent, left, right. And what we want is we want to remove the empty parentheses that will not affect the one-to-one mapping relationship between the string that we'll generate and the original binary tree. Cool, so let's see how we do this. So we have this, for example, this tree, 1, 2, 3, 4. So the first number, no need for a parentheses for it, right? And then after that, the left. So the subtree of this node 1 needs to be between parentheses. So that's what we have here. And the parent first is 2. And then as we go to the children, we nest more parentheses. So we have 4 here. And then the right side also between parentheses, right? Now, if you don't do any processing to remove the empty parentheses, because we have an empty node here on the right, you may get 2, 4, and then an empty string like this on the right. But and similar thing, because there is an empty subtree here, so both left and right side are none. You will get both empty parentheses, right? And so we'll need to prune these because they don't add any value, and so we could just not add them, right? But one case where we would need to add them is, let's say we didn't have 4 here, right? We don't have 4, but maybe we have a number here, let's say 5, right? In that case, we would have to include the empty parentheses, right? Because otherwise there is no way to distinguish if this 5 is the left child or the right child. Because if we remove the empty parentheses here for the left side, then we won't know whether 5, we would have 5 here, we won't know whether 5 here is a left or right child, right? So we need to keep it. So in some cases, which is basically just the case for the if the left node is none, we need to check if the right node exists, because if the right node exists, we shouldn't remove the empty parentheses, right? So that's the main idea here. Yeah, and so that's pretty much it. If you take a look at the second example, we will see what I said here about we want to leave the empty parentheses if we have a right child and the left child is empty, because we want to be able to distinguish whether this 4 is the left or right child. Yeah, so that's pretty much it. Now let's code up this solution. So let's get started here. So we need to do a pre-order traversal. So here we have DFS on a node, and we do if not node. So this is just the base case. We want to return an empty string, right? And of course we want to call it first on the root, and we want to return the result there. And here we want to first, this is pre-order, right? Which means first we process the node, then we go left, then we go right, okay? So for processing the node itself, we don't need to put it between parentheses, because if you take a look here, just for the root even, we start with the number, right? And so we can just here for the node, we can just start a string with the node value. And now we want to go left here. So this was the processing step. We know we want to go left, and we want to go right. But what should we do for the parentheses here? So we said for the right side, we want the value, but if it's and we want to put it between parentheses, right? But if the right side is null, right, like in this case here, then we don't want to have this empty parentheses, because we can tell this is the left child and so we can remove the parentheses. And by that, it means basically if we only go right if the node dot right exists. If it doesn't exist, we don't even bother. And so here, for the right child, we want to start and put it between parentheses. Like let's say for 3 here, we put it between parentheses, right? So if we go right, we want to put parentheses and then put whatever is in the right subtree. Because when we start on a node of a subtree, we only take the value. So we need before that to add it between parentheses. So that's what we do here. Now we want to do the same thing for the left child. But what is the condition that we should do here? So if, as we said, let's say in this example here, if the node dot left doesn't exist, right, we do want to include the empty parentheses still, right? However, if both don't exist, right, we don't want to have 2 empty parentheses, right? That's not useful. Here we only keep the right empty one because we want to distinguish whether this is the left or right child, which means here we need to check both. We need to check if node dot left is present, we want to include it, or if node dot right is present, because we want to include the parentheses for the left so that we can tell this is the right node and not the left. And so here we want both to exist. We want either of them to exist to decide to go left and add the parentheses, right? And that's pretty much it, and we want to return S here. So yeah, so in a nutshell, we add the node, we want the left side between parentheses, the right side between parentheses. Each of them we want to do it if the node exists. If there is a number, then we want to do it. However, for the left side, even if the left doesn't exist, but if the right exists, we want to put it between parentheses. Yeah, so however, for the left side, even if the left side doesn't exist, but the right side exists, we want to add the empty parentheses. So this would go to none and return empty. We want to add the empty parentheses so that we can distinguish the right. We can distinguish the right node, like in this case here. Yeah, so that's pretty much it, I think, for this problem. Pretty straightforward pre-order traversal. The main insight is this here. And yeah, that's pretty much it. Please like and subscribe, and see you on the next one. Bye.